probability of an event E plus probability of an event not E is equal to 1. You should always remember that the probability of E plus the probability of opposite of E is always equal to the probability of an event that cannot happen is what would be this event. Such an event is known as cannot happen is if it is a zero event. Okay, if it is not happening, okay, such an event is known as impossible event. Probability of an event that is certain and it needs to be happen, that is, I can say that is certain to happen is 1. Okay, such an event is known as, I can say it as a certain event or a sure event, certain or sure event. S-U-R-E, sure event. So this is clear. Now, the sum of the probabilities of all the elementary events of an experiment is how much? 1 only. The probability of an event is greater than or equal to 0. You should write here 0 and less or equal to 1. Okay, so this is the limit of an event. The probability of an event is the limitations of an event. Okay, it's equivalent or equal to 0 or maximum is 1. So the minimum possibility of an event is 0. The maximum, let me write, the maximum of an event is what? 1. Hope it is clear. And you need to explain it as well. Okay, now let's do the first one. A driver attempts to start the car. Now, if it is, see, if he may start or it may not start, right? Means the chances of this one is and this one is 50:50%. Hence, I can say that this as your equally likely event. Hope this is clear to everyone, right? So let us look at the next one. A player attempts to shoot a basketball. He or she shoots or misses it, right? Eventually, this is also looking like this one. It's also even this is also, I can write, equally likely. Hope this is also clear to everyone, right? Let's look at the next one. A trial is made to answer a true or false question. The answer is right or wrong. See, eventually the answer might be right or eventually the answer might be wrong. Hence, I can say that it is also an equally likely event. Right? So let us look at the next one. You have a small, the chances of it needs to be this one or this one is how much? It is equally likely. You cannot say whether it will be a boy or girl, right? So if you look at all this one here, the answers are half to half. Hence, these are known as equally likely events. So it's clear. Let's look at the next one. Is something like this: probability of E plus probability of E bar is equal to how much? 1. This is already given. I'm substituting this one here. Plus probability of E bar you need to remove is equal to 1. I need to shift this one over here. So that probability of E bar is equals to 1 minus 0.05. Now we need to subtract the value of 1 and we need to subtract this from the value of 1, right? So the resultant of this one is how much? The resultant of this one is this much, isn't it? So the probability of this one, probability of E bar, okay, the probability of E R is equal to, let me write it here neatly, probability of E bar is equals to how much? 0.95. Hope this is also clear. Probability of A bar is equals to 0.95. Let's look at the next sum. Okay, now you have some picture, like see how we do this. Now you are having a bag here. Okay, yeah, okay. In a this we are having lemon candies. We are having lemon candies in this one, no doubt up to here. Malai takes out Malini. I'm sorry, Malini takes out a candy without looking into the bag. Now you need to remove these two here. Okay. So let us look at the first one. Here he wants to take out orange. She wants to take out the orange candy. Okay. The probability of an event. So let me write here N of E. N of E is your required event is equivalent to what is required? You require orange. The answer is how much? 0 only. So this is your probability. Events are how many? 1 only. And the sample of elements are how many? 1 only. So then of S. So this is clear. Here I'll get 1 by 1. So overall answer is how much? Only 1. And this is 1 here. Okay. So the required probability of this one is 1. Hope this is also clear to everyone. Removes only the hearts. Okay. Hearts are how many? Hearts are only 13 in this. So by the time removing that one out, only 39 is left out. Hope this is clear to everyone, right? This is your hearts. Okay, heart, yes. Okay, hearts. So let us look at the first bit. How do we do this? First bit. So what is your required event? The required event is to be a ace. So what would be the number of aces left? The number of aces are left is 3. What is the sample element? Sample element is your total element, that is your 39. So therefore the required probability of getting a is how much? Is 3 by 39. If you divide this with your 3 table on in the numerator and denominator, this is your resultant. So let us look at the second bit as well. Getting a diamond. Okay, so the required event is getting a diamond. So the number of diamonds available are only 13. Okay, so what is the total number of this one we are having? Sample elements we are having, 39. So therefore the probability of getting a diamond is your N of E by N of S, like this. So when I'm dividing this, the answer is only 1 by 3. So this is clear. So let us look at the third bit here. Now if you are looking at the third bit here, what is the probability of not getting a heart? Okay. So N of E is your not getting a heart. But if you look over here, we have removed them, right? So there are no hearts at all. So 0 hearts. So therefore your N of S sample limit is how much? It's your 39. Substituting this in the formula probability of E, that is your N of E by 0 by 39. So the overall resultant is how much? It's only 0. So let us look at the last bit. Getting a ace of hearts. Okay, so let's see here how would we get the ace of hearts. Okay, if we drop one of the hearts is, so the probability of this one is how much? 1. Okay, so the sample element is how much? The total number of aces are how many? They are only 13, right? Hope this is clear to everyone. Okay, so out of those three, we are removing this one now. That is, total number of outcomes are 13. So the probability of getting a ace of heart is how much? 1 by 13 only. Okay, you should be remembering the difference. So you should be remembering this. How is this? If it is divided, this is divided as 13, 13, 13, and also 13. So if you look into this one deeply in your textbooks, you will have this information. Look through that. Okay. Not having same Earth day. That is your date and year. That is, probability of this one gives us 99.2 something, right? 0.992 something. Okay. Then what is the probability of having two students having the same birthday again? Okay. So let's see, that is having two birthdays. So let me take that probability of E as students having same birthday. Same birthday. Hope this is clear to everyone. As in the earlier sum, we have seen that probability of E plus probability of E bar is equal to how much? 1. And when I'm substituting the values of probability of E bar and having something like this, I'm shifting this one to the RHS side here. So probability of E is equal to how much? 1 minus 0.992. If you're subtracting this, the answer is quite simple. 0.008 is your required answer. Hope clear to everyone, right? So let's look at the next one here. The sample element n of s. When I'm rolling it die, the number of outcomes are 1, 2, 3, 4, 5, or a 6 number on the dice. On the dice. Isn't it? So let's look at the next one now. So here n of s is how much now? Look at the number of elements you're having. It is your 6, right? So let us look at the first bit now. The first bit is n of e is a prime number. A prime number, that is a prime numbers are, what are the numbers in this one? We are having a prime number. That is, the prime numbers are 2, 3 and 5 only. Okay. So the number of outcomes of this one is how much? 3. So this is your n of s. You remember that this is I'm sorry, this is your n of e. Okay. So the overall probability of e, this is your n of e. Remember it. Okay. Is equals to n of e by n of s. That is 3 by 6. That is 1 by 2 is your answer. Hope this is clear to everyone, right? So let us look at the second bit. What is this? A number lying between 2 and 6. That is, the numbers are, what are the numbers? 3, 4. So what are the numbers? 3, 4 and 5. So the required probability is how much? I'm sorry, not the probability. The required sample events is how much? The required number of events is how much? N of E. So this sample element, you know that n of s is equals to 6. Therefore, the probability of the event is equals to n of e by n of s. So this is nothing but 3 by 6. Again, the answer is how much? 1 by 2 only. So let us look at the third one. Now, when die is rolled, the outcome needs to be an odd number. Odd number is 1, 3, 5, and that's it, right? Yeah. So here n of e is how much? N of e is again 3, right? 3. So here n of s is how much? 6. So the required probability of getting an odd number is also 3 by 6. That is 1 by 2. Hope this is also clear to everyone, right? Okay, let us look at the next one here. The probability of selecting out a red thing from a deck in the total deck, you are having how many? You are having 52 cards. So this is clear to everyone, right? Okay. Now the red king. What is the probability? That is your required event is probability of let me write not probability. Number of favorable outcomes. Number of favorable outcomes. That is 2, 1 red thing, right? So you are having only 2 like that. Okay. So I can write here n of e is equals to how much? 2. That is the probability of getting a red king is how many? 2. That is your event. The sample element is how much? N of s is equal to 52. So therefore the king is n of e by n of s only, isn't it? So this is how much? This is 2 by 52. So if you're dividing this, you'll get 1 by